Okay, for the last part, we go to Python language, how to write thread processing in using Python. Okay, so the Python parallel programming ecosystem. Okay, final chapter, final subchapter of final chapter. Last ni. Okay, so the example here, okay, the maximum number of processes can be run. So the maximum number of processes you can run at a time is limited by the number of processes in your computer. If you don't know how many processors are present in the machine, the CPU count function is multiprocessing will show it. So boleh guna multiprocessing as MP ni, import ni, and then type mp.cpu_count. So print je ni, so dia akan keluarkan number of processor. Okay, the other synchronous execution. Asynchronous execution is one the process are completed in the same order in which it was started. This is achieved by looking the main program until the respective process are finished. Okay, asynchronous pula, asynchronous execution, on the other hand, doesn't involve locking. As a result, the order of result can get mixed up, but usually gets done quicker. So we can create a process which print the assigned ID. So by subclassing multiprocess.process, you can create a process that runs independently. So by extending the init method, you can initialize resource by implementing process.run method, you can write the code for the subprocess. Ini je, process.run. Ini kan main lah, macam main kita kan. Alright, so example here, kita guna class multiprocessing dengan time. Okay, so class pula dah. Kita pakai library multiprocessing dengan time. Kita import multiprocessing and import time. Class process multiprocessing.process. Okay, kita define init, self ID, super process. Okay, nampak sini ada init lagi. So self ID sama dengan ID. So bila kita run print je, I am the process with ID. Alright. Boleh try ni. So create a process which print the assigned ID. To spawn the process, we need to initialize our process object and invoke process.start method. Here process.start, we create a new process and we invoke the process run method. So the code after p.start will be executed immediately before the task completion of process p. So to wait the task completion, you can use process.join. So dia tak banyak, dia .start, .run dengan .join. Okay, daripada yang tadi, kita letak p sama dengan process. So p.start, p.join, dah ada satu. P.process yang kedua, atas tulis kosong satu kan. Alright, so p start and then p join. Dah, itu je. So maksudnya kalau kita buat yang contoh dalam assignment kita kan, nak kira cube ke apa, kita boleh buat split by this. Ada 4 kan. 4 kan, 4 proses. Proses 0, proses 1, proses 2, proses 3 kan. Okay, cara lain kita guna pool class. Pool class can be used for parallel execution of function for different input data. So the multiprocessing.pool class spawn a set of process called worker and can submit tasks using the method apply, or apply async and map async. Okay, ni nama-nama dia, nama-nama method yang kita boleh panggil dalam multiprocessing.pool. For parallel mapping, you should first initialize a multiprocessing.pool object. So the first argument is the number of workers. If not given, that number will be equal to the number of cores in the system. Alright, so nanti saya kena tunjuk video lah kan, untuk buat contoh ni, ataupun boleh dapatkan video-video daripada senior lepas kan, ada insyaAllah boleh jumpa kan, macam mana dia orang benda ni. Okay, contoh ini guna pool lah. Ini buat square kuasa 2, maksudnya dia akan return x kali x kan, nampak tak? So yang ini kita buat macam ni lah. Multiprocessing dot pool. Proses sama dengan 4. So input 0, 1, 2, 3, 4. Dah 5 ni. So output pool dot map square input. So input format output format output. Itu je. Alright. So nak hands on pun tak sempat. Kita tengok teori dulu. So concurrent network server type application that communicate with many clients simultaneous demand both a high degree of concurrent and high performance from the I/O subsystem. A good web server should be able to handle hundreds of thousands of concurrent connection and service tens of thousands of requests per second. Ni kalau buat server pula. Tadi satu komputer ada multiple process CPU kan untuk handle satu job kan. Sekarang ni kita nak pakai server, ada multiple server pula kan. Pernah dengar clustering? Alright. So ideally we would like to write this kind of application using thread. A thread is the right abstraction. It allows the developer to focus on programming the interaction with a single client and then to leave this interaction to multiple clients by simply forking many instances of the single client interaction in separate threads. Okay. So maksudnya ada multiple servers. Dia nak run satu website saja, nampak tak? Kan, tapi klien banyak lah. Kan? So maksudnya kat situ kita boleh nampak banyak proses dan banyak thread. So what we need depan ni, kita kena ada connection yang depan, kita panggil dia sebagai load balancer. Dia akan bagi kat mana server mana yang proses. So what we call is clustering in network. So the final conclusion, there are various ways to implement parallel processing using the general procedure and multitasking module. So taking advantage of this benefit is indeed the same for any size machine. The result will gain speed depending on the number of processors when the procedure are followed. Exactly, this is the beginning of knowledge of parallel programming, which we started by using Python language. So in network programming, this parallelism we can accomplish by using concurrent network server. So alhamdulillah, kita dah sampai ke penghujung. Alright, so that's all for ITT 440. You can use these references for further knowledge.